Hello guys, welcome back for another lesson. This will be 5.6, Unit 5, Section 6, and it's titled The Remainder and Factor Theorems. So theorems are sort of like rules in mathematics. You probably did a lot of postulates and theorems and stuff like that in geometry. Probably bringing back a good memory, but yeah, so this is what it's called, and we're really just going to be applying these theorems. I'm going to, in the notes, tell what they are, do a little example, but of course when we get down to the actual assignment, I'll do the evens and just sort of demonstrate what you're going to be asked to do. So, okay, the remainder theorem. The remainder theorem basically says, and this is a summary in my words, if you looked it up online or in a math book, it'd probably look quite different, but the remainder of a polynomial division is the functional value of the divisor. Now, I don't know if you follow that, understand what that means, so that's why I have an example here. So I've got a polynomial, f of x equals x squared plus 2x minus 1. That's a polynomial. And then I've got a value, 3. So when I say functional value basically means plug a number in. So the functional value of 3 essentially means plug 3 into the function. So instead of x squared plus 2x minus 1, it's 3 squared plus 2 times 3 minus 1. And this, of course, works out to be 9 plus 6 minus 1, which 9 plus 6 is 15 minus 1. 15 minus 1 is 14. So that's what the functional value is. The remainder theorem basically says you can get the same answer by doing division. And we learned two types of division, long division and synthetic. And if you skipped that synthetic division section, I think it was 5.5 part 2 maybe, but I'm going off of memory, I could be wrong. Anyway, the synthetic is the easier way to do it. So here's what I've done. I've set up a synthetic division problem. The 3 is the divisor, that's the number in front of this bracket. And then the dividend, the rest of the problem, is the coefficients, which are 1, 2, and negative 1. That's where these numbers come from, 1, 2, negative 1. And in case you don't quite remember the method for carrying this out, you bring the first number down, multiply these together, 3 times 1 is 3, and write that answer here. And then combine these, add them together, 2 plus 3 is 5, write it here. And then you just repeat the process, multiply these two numbers, 3 times 5 is 15, write that answer here. And then combine these two numbers together, negative 1 plus 15 is 14. The remainder theorem basically states that the remainder is the same as the functional value. So that's what the remainder theorem is. Why do we care? What's the deal? I'll talk about that a little better when we get to these examples. You see that basically the first set of problems is going to be the remainder theorem. That's about half the lesson. Now the second is going to be the factor theorem. So we need to talk about the factor theorem a little bit. Oh, well, I guess I skipped a line here. Use the remainder theorem to do what's called synthetic substitution. So that's what the homework is going to be. Like I said, I'll get to that in just a minute. The factor theorem states that if the remainder of a polynomial is 0, then the divisor is a factor of the polynomial. So think about this with numbers, okay? Forget polynomials and algebra for a minute. Let's look at two examples, like 20 divided by 5 compared to 20 divided by 6. And let's do old school division. 20 divided by 5 goes in 4 times, and there is no remainder. That means that 5 is a factor of 20. If it divides out with nothing left over, it's a factor. 5 is a factor of 20. Compare that to the next example, 20 divided by 6. 6 goes into 20 3 times. 3 times 6 is 18. Subtract that, you get 2. So it's 3, remainder 2. Because there's a remainder, 6 is not what we would call a factor of 20. It doesn't divide in evenly. So the factor theorem basically says the same thing goes for algebra. Or I'm sorry, for algebraic, polynomial expressions. So if I had like x cubed plus 5x squared minus 6x plus 2, that's a polynomial, and I divide that by x minus 4 using maybe the synthetic division that we did before, so that'd be 1, 5, negative 4, 2, and then the divisor, remember when it's written this way we use the opposite of that number, By the way, let me compare that to what I did up here. This does not say x minus 3, it says x equals 3. So I used the number, 3 itself. I did not use the opposite of that number. Down here, it's not x equals 4, it's x minus 4. This is the situation where I use the opposite of that number. This goes back to the previous lesson where we did it this way. So opposite of that number is 4. But anyway, bring this down, 4, add, multiply, add, multiply. 32 times 4 is 124, add 126. The remainder is not 0. Therefore, x minus 4 is not a factor of that polynomial. If the remainder had been a 0, then we would say that is a factor. Okay. Let me get past these notes and get into the actual examples, and hopefully if you have any confusion, after I do several examples, you'll see exactly what you're expected to know. So, evaluate each given function at the given value. To evaluate, before today's lesson, to evaluate, what you would do is you would do negative 2 to the third power plus 6 times negative 2 to the second power plus 2 times negative 2 minus 19, and then you would have to work this out. Go through all the steps, do all the arithmetic, etc., etc. Whatever answer you get is the answer to the question. Maybe just for kicks I'll do it one time, but that's not the point of this lesson. You don't want to do this. Don't do this. I'm only doing it this once just for demonstration purposes. So negative 2 to the third power works out to be negative 8. 6 times negative 2 squared, that's going to be 6 times 4. 2 times negative 2 is negative 4 minus 19. And then 6 times 4, so this is going to be negative 8 plus 24 minus 4 minus 19. Negative 8 minus 24 is 16 minus 4 minus 19. 16 minus 4 is 12 minus 19. 12 minus 19 is negative 7. So look at all this work. Look at all the steps I had to do to get the final answer. Here's what you are going to be expected to do. Set up a synthetic division problem. So you put negative 2, this number, out front, and then 1, 6, 2, negative 19. So 1, 6, 2, negative 19 goes inside the division bracket, sort of the upside down division bracket. And then the process, once again, you bring the first number down, multiply those. Negative 2 times 1 is negative 2, put it here. Add those together. 6 plus negative 2 is 4. Multiply those, that's negative 8. Add 2 plus negative 8 is negative 6. Multiply those together. Negative 2 times negative 6 is 12. Negative 19 plus 12 is negative 7. Oops, that negative sign was kind of funky. Negative 7. And there it is. Same answer. Generally speaking, when you get good at doing synthetic division, it's a lot easier than all of this work over here, doing it like the traditional way. You usually don't draw these arrows in the whole process. I tend to always draw this arrow because the first step is always bringing that number down, but all of the extra drawing kind of gets in the way and confuses the issue. So what I'm going to do for the rest of, 2, 4, and 6 is I'm going to repeat this process, show you the way that I would do it, and suggest that you do it the same way. So let's look at number 4. Oh, I'm sorry, we like to check our answers, don't we? So number 2, the answer, holy cow, the answer is negative 7. All right, now you are showing your work on these problems. Just want to emphasize that. So to do number 4, I put this symbol down, a 3 out here, 1, negative 3, 3, negative 14, 4 goes there. Bring this down, multiply. 3 times 3 is 9, write it there. Add negative 3 and 9, it's 6. Multiply 3 times 6 is 18, write it there. 3 plus 18 is 21. Multiply 3 times 21 is 63. Add negative 14 plus 63. That's the same thing as 63 minus 14. 63 minus 14 is going to be 50. 49. Ooh, this doesn't look good. 3 times 49. Well, 3 times 50 is 150. 3 times 49 is going to be 147. 4 plus 147 is 151. Oh, that I don't remember seeing that answer. Oh, I hope I didn't do number 4 wrong. Yeah, that's okay. Well, that doesn't inspire a lot of confidence, does it? I screw it up and ask you to do the same thing. So let me make sure I didn't copy anything down wrong. So 3 goes here. 1, 3, negative 3, positive 3, negative 14, positive 4. 1, negative 3, positive 3, negative 14. So I set it up all right. Did I do just a silly adding or subtracting mistake? Let me see here. Bring down the, oh, I'm dumb. Oh, how stupid. You bring down a 1. Good grief. All right. We'll start this over. Man, I would just stop the whole video and start it over, but that's probably not worth it. Yeah, we'll just move on with this. Learn from my mistake so you don't make them yourself. You bring down the first number, that's a 1. You multiply, 3 times 1 is 3. Then you add, negative 3 plus 3 is 0. Then you multiply 3 times 0 is 0. Add 3 plus 0 is 3. Multiply 3 times 3 is 9. Add negative 14 plus 9 is negative 5. Multiply 3 times 5, negative 5 is negative 15. Add 4 minus 15. Add 4 plus negative 15, that's negative 11. And that is the answer. Good grief. So yeah, negative 11. You know, I'm not going to make excuses. Let's just say it's good every once in a while if I make a mistake, if you can learn from it. And what did we learn from this mistake? Well, I'll show you on number 6. So here's my bracket. This number goes out here. These numbers go across the top. So negative 2, negative 3, 22, 10, 2, and negative 15. Extend that out a little bit and erase all these circles. Okay, so here's the mistake I made. You are supposed to bring this number down and write it there. I didn't do that. I don't know what I did. I think I wrote this number here for some reason on that last problem, and that was my mistake. So just a dumb mental lapse. Anyway, so you start out by bringing the first number down and then multiply those. All right, I said I wasn't going to draw arrows. I'm not going to draw arrows. Negative 4 times negative 2 is 8. Negative 3 plus 8 is 5. Negative 4 times 5 is negative 20. 22, negative 20 is 2. Negative 4 times 2 is negative 8. 10 and negative 8 is 2. Negative 4 times 2 is negative 8. 2 plus negative 8 is negative 6. Negative 4 times negative 6 is positive 24. Negative 15 plus 24 is 9. 9 is the answer to number 6. Please let it be the answer. There it is. So, again, this is a process. We're using the remainder theorem. It is often called synthetic substitution. The traditional way to answer a question like this is to actually substitute this number into the equation and then do all that math, and it can be a complete pain to work all that out. The idea is that synthetic substitution is, I'm going to do air quotes here, not that you can see it, but air quotes, easier. It's easier work because technically all you're doing is you're multiplying and adding, multiplying and adding, multiplying and adding, multiplying and adding. The whole process is accomplished by multiplying and adding. Here you have to use powers, you have to add, subtract, multiply, and it just seems like it's more work. So synthetic substitution is an alternative to traditional substitution. We use synthetic division to get it done. So that's what I want to see you do on 1, 3, and 5. This can still be an overall tedious problem, a tedious exercise. So that's why you only have 3 problems instead of a whole page of these. Yeah, well, I guess it does fit in a page, but like instead of doing 10 or 12 of these, just 3. But that takes us to the next section, which is a little more work, I hate to say. So we are asked to factor each of these polynomials, and one factor has been given. So in number 8, this is the given polynomial, and x minus 3 is a given factor. So here's what we're going to do. I'm going to use synthetic division. Now you could do long division. If you remember last week we did both, long division and synthetic division. They both accomplish the same thing. It's up to you to do whatever you like. I'm going to go ahead and choose synthetic division because it kind of goes with the whole synthetic substitution up here. Now in this scenario, we use the opposite of this number, so positive 3, and then put 1, 6, negative 20, negative 21. It's critical. You have to use the opposite of that number. Bring this down, I get 1, multiply, you get 3, add, 6 plus 3 is 9, write it down, multiply, 3 times 9 is 27, add, you get negative 20 plus 20 is 7, 3 times 7 is 21, add, you get 0. Again, the fact that you get 0 assures us that what has been given is indeed a factor. Now, what about the 197 that's left over? Well, the original problem was a third degree polynomial. Starts off with x cubed. Our answer, or I'm sorry, not the final answer, but what we have here, this answer, is going to be 1 power less. So 1 power less. So this is going to be 1x squared. You can write the 1 there. You don't really need to. The positive 9 you'd put down as plus 9x, and the positive 7 is plus 7. If you did not do this lesson last week, you need to go back and redo it just to make sure. Now, give me just a moment. I need to check on something. I need to cheat and look at the answer a little bit. Okay, you see that answer right there? X squared plus 9x plus 7, x minus 3. So here's what we are supposed to do. You're supposed to look at what you have left and say, okay, can I factor this using any of the traditional means? And that's where you put an x here, and then you look for two numbers that multiply to 7 and add up to 9. We've done a ton of this. It turns out that the only options for multiplying to 7 is 1 and 7. There's no other choice. And 1 and 7 do not add up to 9, which means that you cannot factor this any further. So the fact that that cannot be factored means that your final answer is this, x squared plus 9x plus 7, times the factor that was given, x minus 3. So this is in factored form. Okay, so we've previously learned all types of factoring. There's trinomial factoring, grouping, difference of cubes, sum of cubes, difference of squares, lots of stuff. That all still applies here, but that first factor we're going to actually divide out using synthetic division. All right, let's look at some more, make sure we hopefully fully understand this. Okay, so next is 6, negative 37, 47, 20, and we need to divide by that. Now, if you recall, here we don't put the opposite of this number because you have a lead coefficient there. So what you're supposed to do is set this equal to 0 and solve it. 2x equals 5, divide by 2, 5 halves. Oops. 5 halves becomes the divisor. So we went over this again last week, and I can't emphasize enough. If you skipped this lesson, go back and do it, the one on synthetic division. Instead of doing all this work over here, I gave you a bit of a shortcut. So like in these problems, you use the opposite of this number. If you got a problem with a lead coefficient here, you do the opposite of this number over that number. So opposite of negative 5 is positive 5 over 2. It's the same thing. You just, if you're good at remembering little tricks and tips, there you go. If you're not good at remembering it, you got to set that equal to 0 and solve it. Okay, now let's do this process. Oop, didn't mean to erase that. Bring down the 6. Multiply 5 halves times 6. If you're not good with fractions, turn on a calculator, type in 5 halves times 6. It's okay. Without a calculator, 1 half of 6 is 3, so 5 halves of 6 is 5 threes. 5 times 3 is 15. Add those together. Negative 37 plus 15 is negative 22. Am I right? So 5 from 7 is 2. 1 from 22. Multiply 5 halves times negative 22. There I go again with my arrows. Half of negative 22 is negative 11, so 5 halves would be 5 times negative 11, that's negative 55. Add those together, 47, negative 55 is negative 8. Yep. 5 halves times negative 8, well, half of negative 8 is negative 4. 5 times negative 4, 5 times negative 4 is negative 20. 20 minus 20 is 0. As we expect, a 0 remainder. That means that this is a factor. Since they told us it was a factor, obviously this is just verification or validation, whatever you want to call it. Now at this point, I don't know if you remember these special problems with a lead coefficient. You have to now go through and divide all of these by 2, whatever that number is. You got to do that. So you get 3, negative 11, negative 4. So call this 3x squared, right? Our original power was 3. 3x squared minus 11x minus 4. And now we need to factor this out, if we can. So in the last problem, I tried to factor this, and I couldn't. So we're pretty much done. Let's see if this one factors. So 3x and x. Need two numbers that multiply to negative 4. Let's try, 1 and 4. Now if I multiply the outside, that's 12x. The inside is 1x. Can I combine those in any way to get negative 11? Yeah, a negative 12 and a plus 1. So if I put a negative in front of the 4, that's negative 12, and a plus there is plus 1. So there we have it, trinomial factoring. So this factors into that. Take the original factor that was given and tack it on at the end. And that should be the final answer. So number 11, let me check, or number 10, let me check that. And that indeed is what it's supposed to be. So kind of complicated. We are using previous skills. So from what I did from here to here is a previous skill. The synthetic division technically is a previous skill because we did a lesson on it already. And I say if you haven't done that lesson, go back and do it. The reason I say that is because I'm grading homework all the time, and this seems to be one that a lot of people have skipped. Every so often people seem to choose to take zeros on lessons, and this is one of them for some reason. All right, let's try number 12. Now this time, 2 factors have been given. So this is what we're going to do. We're going to set up a synthetic division problem. And so it's 1, negative 14, 32, 14, negative 33. And I'm going to go ahead and divide the first factor out. So I need to use the opposite of negative 3. So that's going to be positive 3. Bring this, nope. See what I did? I was about to make that same mistake. Bring down a 1. Multiply 3 times 1 is 3. Add negative 14 and 3 is negative 11. Multiply 3 times negative 11 is negative 33. 32 plus negative 33 is negative 1. Multiply 3 times negative 1 is negative 3. Add 14 and negative 3 is positive 11. Positive 11. 3 times 11 is 33. Add those, you get 0. So again, that's just verification that this is a factor. But now what I'm going to do is take the answer I just got and do a second synthetic division on the second term, or the second factor, x plus 1. Again, use the opposite of this number, minus 1, and repeat the whole process. Don't know why there's a dot there. Okay, bring this down. Negative 1 times 1 is negative 1. Add, you get negative 12. Multiply negative 1 times negative 12 is positive 12. Add, negative 1 plus 12 is positive 11. Multiply negative 1 times 11 is negative 11. And again, we get a 0 remainder, which verifies that this second factor over here actually works. Now, 1, negative 12, 11. That equates to 1x squared minus 12x plus 11. Now, hold on for a second. We started out with a 4th degree polynomial. Why is that a 2? Because we talked about how it decreases by 1. Well, in the first step, it decreases by 1. So this would have been 1x to the 3rd, 11x squared, etc., etc. But now if we take this one and decrease it by 1 again, that's why we're down to x squared. So that's why we went from x to the 4th to x squared. Now I can take this and factor it, x and x. So what times what is 11 and adds up to negative 12? 1 times 11 is 11. Negative 1 and negative 11 is negative 12. Combine that with what was given, x minus 3, x plus 1. And what we have is the original polynomial is now completely factored. Let's check number 12 and make sure that's right. And minus 1, x plus 1, looks good. All right, one more and we are done. Number 14. Okay, number 14, I could just start off like the rest of these problems, but there's something special about 14 and 13. So when you go to do your homework, it's going to be a lot like this. So do you see how every term in the original problem has an x in it? That's what we call a common factor. So I can actually do common factoring before I do the rest of the problem. If I factor an x out of every one of those terms, I'm going to get x to the third plus x to the second minus 4x minus 4. Now, kind of set that aside mentally. We're not going to deal with it. What we are going to do is go ahead and do the synthetic division just like all the other problems. Positive 2, going to be the divisor. 1, 1, negative 4, negative 4. That's this coefficient, that one, and that one. Go ahead and do the process. Bring down a 1, multiply, add, multiply, add, multiply, add. We get a 0 remainder. That's good. That's what we're supposed to have. We had a third degree polynomial. It was a fourth, but when we factored out the x, it turned into a third. Now when we do synthetic division, it narrows down to a second degree polynomial. So that's x squared plus 3x plus 2. Now try to factor this if you can. X and x. 2 times 1 is 2, plus 2 plus 1 is 3. So we've got that, x plus 2, x plus 1. We have the original factor, which was given, which was x minus 2. And we have this extra x right here, which I said sort of mentally just set it aside for a minute. But that x did get factored out, so we still have to attach it to the final answer. And there it is. Number 14, completely factored, should look like that. Let's check number 14. X plus 2, x plus 1, x minus 2, there it is. So it's kind of, potentially tricky. If I were to just summarize it, I say in general, you set up synthetic division. Of course, these numbers go up here. Opposite of this number goes here. Whatever you get is going to be 1 degree less than what you started with, in this case, x squared, blah, blah, blah. What you get here is going to factor, or maybe it could be prime, maybe it won't be factorable, but generally they factor. Once you get that figured out, take the given factor and attach that at the end, and that should be your answer. That's the overall flow of these problems. Yes, you got one where it's a little different with that lead coefficient. You got to follow slightly different rules to make it work. And you've got this one where you have to do 2 factors, 2 divisions instead of 1. Oops, where am I going? Kind of like that one. And then you've got this one where there's a common factor. I'm going to sneeze. Oh, so sorry, guys. I wish I had a quick, probably do have a mute button somewhere on my headphones, but sorry. Anyway, number 13, you got this extra factor of x. Like I did here, you have to do common factoring. But if you follow my notes, you should be able to do this assignment with no problem. However, if you do have a problem, contact me whatever way you can, whatever way you're comfortable, and I will do my best to help you out in any way that I can. I'm just going to erase all this before I sign off and save it. So erase that, erase those little marks, and that is it. All right, till I talk to you later. Have a